Yes, dear friends, now I start here some new topics which are remain in magnetism. First of all, I told you in last chapter, I told you the magnetic field produced by current carrying conductor, state conductor, solenoid, and so many pattern of field. And we proved there that whenever there is current, there is magnetic field. In magnetism, you have learnt in lower classes like class 8 about bar magnet, about magnetic field of bar magnet. And there are some materials which you easily note that they are attracted by a bar magnet. But listen, dear friend, every material has some magnetic properties and they are classified in different categories. Number one, diamagnetic. I will take them later on in detail. Here I am introducing you these materials, diamagnetic materials. नहीं दिखाई दे रहा, sorry. Diamagnetic material. Number one, diamagnetic. Diamagnetic material. Number two, para, and number three, ferromagnet. Ferromagnetic material. So I will take them detail. Here I am simply telling diamagnetic are slightly repelled by a magnet. Other way you can say they get magnetized in opposite direction. Paramagnetic is slightly attracted, ferromagnetic is strongly attracted. Iron nails are of the material ferromagnetic material. So just introduction here, name, nomenclature. Actually my aim here to tell you that some terms are there in magnetism which is difficult to learn by students and difficult even learn to teach also. So first term here is magnetic induction. Magnetic induction. This diagram here shows some magnetic field. These lines represent field line of magnet or magnetic field lines. These lines are called magnetic field lines. Magnetic field lines. In this field, we have put a bar of, say, some material like iron. Actually, when we put any material in external magnetic field, then that gets magnetized. And this phenomena is called magnetic induction. Induce something to induce. So we are inducing here when you bring an iron nail near a magnet. The iron nail is attracted. Iron nail attracted by a magnet. And remember, a magnet can attract or repel a magnet. So some magnetic properties are induced. Inducing of magnetic property in a non-magnet is called magnetic induction. So how to measure? In physics everything is measured. In physics everything has to be measured. So how do you measure that? Suppose here we have placed a bar of iron in these field lines. Then some field lines are induced which are shown by dotted lines, broken lines. Arrow give direction of the field induced in the bar magnet. This end becomes north pole and this becomes south pole. So it has its own magnetic field lines, and as a result of this, number of field lines inside the bar become larger than when we see this area without bar. The number of field lines get increased. This number of field line per unit area This is the area cross section of bar magnet. Number of field lines per unit area, total field lines, the original one and the induced one, is called magnetic induction. B, vector B लिखते हैं इसको. It is equal to number of, B, vector B, magnetic induction. B is called magnetic induction. Vector B, magnetic induction. And it is equal to number of field line per unit area of bar. Number of field line per unit area of bar is called magnetic induction. Here in figure B, what is shown? The field line get closer and get increased. So it means field becomes stronger inside the bar, while outside it is weaker. So number of field line per unit volume, per unit area is called magnetic induction. Actually, B is equal to, there is one term magnetic flux, phi. Phi is equal to B. B is the field intensity passing normally. A is the area through which field line passing. So B here is equal to phi upon A. Phi is called magnetic flux here. So magnetic induction is also called as flux density. That is magnetic flux per unit area. Actually, why the word induction has been used here? Field has been increased inside the bar and it becomes itself a bar magnet. Is that clear? So this is called vector B, magnetic induction. Its unit is the same, Newton per ampere per meter. Unit of B, vector B, is Newton or Tesla or Weber per meter square. Small t so. Weber, the same unit which we have learned. In case of current carrying conductor, again field was induced by passing current through the conductor. If we don't pass current, no field is there. So this was something relating the magnetic induction B. Now there is another term. If you want to read this, there is one physics book, Newton Physics, published by Nagin Prakashan Meerut. You can read, and there is a good collection of problems which are asked in every competitive exam, in NEET or engineering test, etc. Now the next term is magnet. The next term is magnetic intensity magnetization. Next term is intensity of magnetization, or simply magnetization, People speak both the way. Intensity of magnetization, it is known as capital M, vector capital M. I told you in last chapter and before, and in this chapter also, there is a net dipole moment. If it is a bar magnet, it has dipole moment. That M equal to, I told you, 2A into capital M. In case of current loop, it is IA. So, the magnetic material which are magnetized, the intensity of magnetization is defined as the net magnetic dipole moment. Magnetic dipole moment, जिसको हम लिखते हैं स्मॉल m वेक्टर पर यूनिट वॉल्यूम, नंबर ऑफ मैग्नेटिक डाइपोल मोमेंट पर यूनिट वॉल्यूम. So if a magnetic material of volume V, so if small m be the net dipole moment in volume V of the material, then intensity of magnetization is given by vector m is equal to small m upon v. Please learn these terms very carefully. Now, what is about unit of intense matter or simply magnetization? The unit of vector m is ampere meter square is the unit of net dipole moment or joule per Tesla also, and volume meter cube. So it is ampere per meter, or you can write ampere upon meter. Unit of magnetic dipole moment is ampere per meter. I told you one more unit, ampere meter. Do you remember? Ampere meter is the unit of pole strength. The concept of pole strength actually is discarded one way, because we measure the magnetic field intensity in terms of force on current carrying conductor. We never define here force, magnetic field force per unit north pole. Initially when we were student, it was told like this. So this was about intensity of magnetization or simply magnetization. What is that? Net dipole moment per unit volume. क्या कभी net magnetic dipole moment, not electric dipole moment, magnetic dipole moment per unit volume is called intensity magnetization or simply magnetization. Now I come to the next topic here, which creates lots of trouble to students. That is called, सुनो भाई, नाम सुन के आपको लगा जैसे हमने पहले पढ़ चुके, मैग्नेटिक इंटेंसिटी, और in one book with me here, strength of magnetizing field भी लिखा है, और we can write simply magnetizing field. Dear friend, I got it after very long thinking and after a long study of different books. Single book would not explain me what is it is not by what is the magnetic intensity H vector लिखते हैं इसको. This is written vector H intensity of क्या भाई sorry magnetic intensity, not intensity of magnetization, that was capital M. It is magnetic intensity or magnetizing field. Actually some authors are using wrong tradition which are left. Some use the magnetic lines of force. There is no criteria, nothing like that. So magnetic intensity क्या है? You have learnt in last chapter a pretty long solenoid having n transparent length. This is a long solenoid having small n turns per unit length of the solenoid, and we pass current I. तो magnetic field जिसको हम कहते हैं B वेक्टर इनसाइड एन एयर कोल्ड solenoid is has magnitude B equal to mu 0 small n I. Here small n क्या है? Number of turns per unit length. Number of turns per unit length, mu 0 n I. But now if we place a magnetic material like iron core, then the core has its own field. Now if we place a magnetic material like iron bar, suppose if we place an iron bar in the core of solenoid, so we get the field due to magnetic field of bar BM लिखता हूँ BM, which is I write B0 here, sorry. BM will be mu 0 into M. M is the intensity of magnetization. BM is the magnitude of magnetic field inside the bar, and capital M, what is this? Intensity of magnetization M. M is the magnitude of intensity of magnetization. So total magnetic field inside the long solenoid when bar is placed is given by B equal to B0 plus BM. So it is equal to, here B equal to mu 0 n I plus mu 0 m, or we can write it as mu 0 common n I plus m, or you can write it as mu 0 into h plus m. In vector form, we write vector b equal to mu 0 vector h plus m vector m, and here H equal to Ni, and H is called magnetic intensity, or magnetizing field. Actually, who produced magnetic field inside bar? This is this H, Ni. So magnetizing field which produce magnetism in different material when placed inside it can be changed by changing the number of current as well as current I. The direction, we have written vector H. Direction can be changed by direction of current. I told you in last chapter कि current अगर ये है तो field this way, current उल्टा है तो field this way. तो H बराबर Ni magnitude, or you can write H equal to here B upon mu 0 minus N. A famous book with me simply defined H as this. Where it is, from where it is coming, that why not given that book. So please learn this topic carefully from this video. Very important. Unit of H. What is the unit of H? By H equal to Ni. H equal to Ni. What is N number of turns per unit length? It is current ampere. So unit of H is again ampere per meter. Ampere per meter. The same as M. M as same unit as ampere, or basically dimensionally they are same. Dimension of H and M same, and is equal to dimension of B upon mu 0. Mu 0 is called here magnetic permeability of free space. Now I will be telling you other thing in next video that become longer. You may feel bored. So please, I request you to read this topic carefully from the video, and if you want, please read NCERT book as well as some other book also. Thank you.